Hi, I'm Alex Dunn, and I created project Suave Keys. Suave Keys is an accessible and distributed keyboard and controller that uses both voice and expression to allow anybody to use any device that they have at their disposal to control software in ways that works for them. It's powered by Azure and cognitive services, as well as a slew of other Windows services like C#, Xamarin, UWP, and more. Suave Keys was built to work right alongside existing and traditional forms of input, such as your keyboard and mouse, your Xbox controller, or even just directly on your phone. But it allows you to use any different device that you have at your disposal to control any other one. That means you can use an Alexa speaker, a Google smart screen, your own phone, and even your own webcam to control the computer or a different mobile device that you have on hand. The process to get started is simple. Sign into your Suave Keys account on the input device, do the same thing on the output device, and then choose your profiles that you're going to be using to map what you say or what you express to what keys you want to be pressing on your end keyboard. The tech stack for Suave Keys allows for support across many different input and output devices. You can use Alexa, Google Assistant, Bixby, custom assistants and extensions on our developer platform, Android apps, iOS apps, and Windows apps as well, all to send expression and voice inputs to your end output devices as either Windows, Android, or iOS and Mac, which are on their way. The entire tech stack of Suave Keys is built on top of .NET and Azure. The back end is a C# and .NET API on ASP.NET Core and uses SignalR to send WebSocket connections between devices. The API is hosted in an Azure App Service and uses PostgreSQL on Azure behind the scenes to handle user record information as well as profile preferences. We then use cognitive services such as Lewis and Face API to handle the natural language understanding as well as recognition of expression and head position to help you control your software. The mobile and desktop apps are all built on top of Xamarin and Xamarin Forms, which means more C# and .NET, and supports currently Android, iOS, and Windows with more Mac support to come. Also, to handle the distribution to the different voice assistants, we're using Voicify to handle Alexa, Bixby, Google Assistant, as well as some custom inputs. Here's the flow of data and what the setup looks like. Everything on the left side is essentially your input device, all your different voice channels, as well as your mobile apps and desktop apps. The voice channels send HTTP requests to Voicify, which has a webhook registered to send to the Suave Keys API in Azure. When those requests come through, it's sending over WebSockets to your authenticated devices for output, such as your desktop app or like a Windows machine. When you receive that request on a Windows machine, we actually send the underlying profile information and what key you're mapping to an Arduino device that then sends true USB keyboard input back, which means that we can control any software, not just ones that support virtual key input. To add on top of this with more cognitive services, we added support for voice and video input on mobile and desktop devices to also help control. That means you can use your Android or iOS device to both talk and visualize with the webcam expressions and inputs through voice to then be sent right back to the desktop app to control the output to the end keyboard. Let's take a look at the setup, how it works, and show a quick demo. Using Project Suave Keys is as easy as signing into your different input devices, your different output devices, and then choosing what profile to use and start sending commands over. For this example, I'm going to be doing all of it within the UWP app on Windows, which will be able to do both the input for microphone, input for video, as well as the output through the Arduino Leonardo to a USB keyboard. So all I have to do to get started on this device is sign in, which I've already done, then choose which hardware device I'm going to be using. In this case, I've got my Arduino Leonardo, which is really an Arduino Micro plugged in here. Connect to it, connect to the online services, and then choose to either use the microphone or the camera. For this example, I'll just pull up a notepad to be able to type things in. But before I actually do that, I'm going to jump over to profiles and choose which profile I've created that I want to use. For example, I've got different games and different software that I might want to play with. For example, if I'm going to be using PowerPoint, I can select PowerPoint, go to Manage Commands, and then map the different things I want to say to the different keys. So for example, if I want to hit the D key, and whenever I say D, or whenever I say next slide, I can enter those and click Save Commands. I can also create macros, so if I wanted to create an entire chain of events that happen whenever I say a given command, I can enter the command name, such as 3 slides, and then choose to add different events. So in this case, I'll press a key, I'll say that I want to press D, and I'll hold it for 50 milliseconds, and then I can choose to either press another key, pause, or type an entire phrase. So whenever I say 3 slides, I'm going to be moving through these entire sets of events on my keyboard. Now that I have this selected, I can choose to use either the microphone or the camera, but I can do this on any given device. For example, if I've signed into the Alexa skill or Google Action by using account linking, I can use that as a microphone as well. For now, I'll go to microphone and say start listening. D. Next slide. So you see, because I said both D and next slide and that mapped to my D on the keyboard, I was able to type that here. If I was using PowerPoint in presentation mode, I can map my D key to actually move to the next slide as well, or use things like arrow keys. Now let's switch over to the camera. The camera allows me to detect head position to control any different key, as well as to allow me to perform an action whenever I smile. So what I'm going to do is go to Profiles, go to PowerPoint, and I'm going to Manage Commands. What I'm going to do is whenever I want to hit A, I can say that I smile. That'll let me either say smile, or I can also just smile directly into the camera. So let's try that out now by selecting the profile again, going to camera, smiling, and then going back to the notepad. And you can see that it typed an A because I smiled at the camera. So that's really all there is to it. You can also go check out the command log to see whenever anything was sent, for example, what key was sent and what the mapped key was or what macro was executed, as well as switch profiles in the middle of you. So if you wanted to switch to a different game or to a different piece of software, you could do that by just going to the profile or creating a new one that you want to use for a different setup. Now let's check out some more use of Suave Keys in action with Alexa, Android, Windows, Snapchat, Twitch chat, and more. Attack. Oh! Attack! Attack! Alright, we're playing one-handed. So I'm gonna keep my other hand here so I can just be like, real quick. Just to see if it's working, I'm gonna use my eyebrows. Little jump, little fist, jump. There's the jump dive. Alright, we're off and running. Oh, Alexa, tell Suave Keys to press attack. There we go. Alexa, tell Suave Keys to press block. I'm extremely excited for the power that Suave Keys brings to enable people to use more devices to control more software more easily, and level the playing field in both the gaming and educational spaces. By allowing people to interact with software in ways that works with them, we unlock a whole lot of new opportunities for people to both learn and use more in the tech that they already have. Thank you for checking out and supporting the project. Hope to see you either on Twitter or on Twitch as we continue to work on this and bring it to production to help reach more people and on more devices, and hopefully see a better future for human-computer interaction that's accessible to everybody.